that is the last part of the discussions that we have today. How we can use different brain stimulation methods, whether they are magnetic stimulation or electrical stimulation. As we talked about, let's say EEG versus MEG, magnetic versus electric, here we also have the same issue. We can stimulate the brain from the magnetic side with the device we call transcranial magnetic stimulation, or with the electrical side, transcranial electrical stimulation. So we can do, now we can intervene. Now we can record, intervene, record again. And that is the beauty of brain stimulation methods. Now we can combine brain stimulation methods with brain mapping. And actually these brain stimulation methods are brain mappings, because we map, when we put the TMS machine over your motor cortex and just go to different parts of the motor cortex to see what is the part of the motor cortex. When you stimulate that, you would have, for example, your thumb twitching, just showing that, okay, this part of the brain is responsible for making this, let's say, abductor pollicis brevis muscle in your thumb. Okay, so you can find that a specific area with stimulating that area. So you can stimulate that, you can see what is happening in that specific part of the hand. So that part is corresponding to that part of the hand. So you are doing the mapping. So that is what we call a motor mapping method. So we can use brain stimulation methods to do mapping, and that is exactly what we do. We put kind of these methods, these kind of TMS machines, and we can make even a map about activations, different parts. I will discuss about these methods in details in the next steps, and how these kind of, even we can do the stimulation with direct currents, we can do a stimulation with alternating current or random noise. So there are different methods of a stimulation. And just going back to what we discussed in terms of that specific granting application. So what I'm proposing for that grant application, what I'm putting together for that grant application, we are going to do a combination between electrical stimulation and fMRI together. We have recently published a paper. Those who are interested to know about the details, how we are combining electrical stimulation and fMRI together, that is a paper that we have recently published with one of the students in City University of New York, Zainab. She's a brilliant student there. Hopefully would be a faculty member somewhere very soon. And what we do, we basically do the stimulation protocols that I told you with frontoparietal synchronization. And what we can do, basically we can do a stimulation in different frequencies. And then when we stimulate two sides, we can synchronize them with different frequencies, and even we can make a phase difference, a little bit of phase difference between the stimulation that we are putting in frontal part and parietal part. Because we know that when we do the stimulation, they are not actually in exactly the same timing. So we can just play with the timing a little bit as well. And there is a large space of this stimulation. But what we do, let me just move forward for that. What we do inside the scanner, we do the stimulation inside the scanner. And what we do in that large space of different frequencies, different phases, different amplitudes, different variations of different stimulatory protocols, what we can do the stimulation, we can record with fMRI, and what we like to have high activation in executive control network. We want to have high activation here and see, okay, if we are there or not. If we are not there in the target brain state, this is the neural target that we discussed about before. Have we been able to engage that neural target or not? Okay, if we are not engaging that, we go to another. So if we have a sort of from frequency of 6 Hertz, we go for 7, we go for 8. So we search within this space, and we do it in a kind of optimized way to be able to not search the entire space, but gradually finding the most optimum part of that space for each specific individual. And we do what we call closed loop fMRI TES neurofeedback. So that is the method that we are developing, and that is amazing if we can do that. And there are challenges for that, so we are kind of working on that in terms of what are the challenges that we have for this specific method. We are developing different electrodes for that, different technologies for that. Hopefully it's going to be something that is going to be interesting for people in the field. So at the end of the day, as the last slide, we have tried to cover these 7 areas in just less than 2 hours time that we had. And I'm hopeful that I was able to give you at least a sense about different methods that we have, fMRI, EEG, DTI, brain stimulation methods, and how these things are going to work together at the end of the day to make an intervention for us, to give us this potential to change the brain state to the state that we are interested to have, especially if we know what is the ideal brain state, if we know the actual target that we need to target. And there are still many challenges. We are not still quite sure what is the ideal brain state for most of the disorders that we have. We still need to explore what are the ideal states. What is the ideal target for us? What is the best area that we need to target? And how we can do the optimized target engagement, and how the optimized target engagement could be reflected at the end of the day in real life behavior and a specific clinical outcome. That is going to be the major challenge that we are going to face in the future.